All right, section 3.3, sums and difference of identities. We're going to consider cosine of a minus b. Please understand it does not equal cosine of a minus cosine of b. You do not distribute the trig function into the argument. If you think that's the case, then say, for example, let's let capital A equal pi over 2 and capital B equals 0. Substitute those in to the original statement. You get cosine of pi over 2 minus 0, which is the cosine of pi over 2, which is 0. And if you did distribute the cosine to get cosine A minus cosine B, then put in your pi over 2 and your 0, you get now 0 minus 1, which is negative 1. They are not the same. So to create an identity for cosine of A minus B, we go to our unit circle. We pick points. I'm going to pick a point A over here in quadrant 2, build this angle. That point on the unit circle is cosine A sine A. This point where I started on my initial side, remember that's over here at 1, 0. Then I'm going to pick another angle, say in quadrant 1. We'll call that angle B. On that unit circle there, that point is cosine B sine B. Now, I subtract these two angles, which is basically saying I eliminate B from A, so that means from the terminal side of B to the terminal side of A is your A minus B. Now, what we want to do is we really can't work with this right now is because we got to have this side on the x-axis. So let's rotate the red and the blue of the A minus B. We're going to rotate them so this side is down on the initial x-axis. And then that, now what I have in black, initial side, terminal side, is the exact same size as what the blue and the red are. They're both A minus B. So this point here, now we can declare it on our unit circle as cosine of A minus B, comma sine of A minus B. And again, we're at our initial point down here at 1, 0. So, to create an identity, we go to coordinate geometry. We're going to find the distance between the red point and the blue point. That was the red A minus B. I should say red and blue A minus B. And we'll do the same thing with the endpoints of the unit circle for the black A minus B. So to find the distance, we need our distance formula between 2 points. So from cosine of A minus B, sine A minus B to 1, 0, you subtract the x-coordinates and square it, subtract the y-coordinates and square it. So I chose cosine of A minus B minus 1, sine of A minus B minus 0. It doesn't matter which order you subtract them in. And then we're going to do the distance from cosine A sine A to cosine B sine B. So again, doesn't matter which order, but because I want to keep this in this A minus B order, we're going to have A's first, B's second. So cosine A minus cosine B, that quantity squared, plus sine A minus sine B, that quantity squared. Well, wait a minute. If they're both inside of a square root, you could just square both sides and cancel that out. So the square roots are gone. Okay, so we're going to have to do some foiling. We don't have to FOIL here because the minus 0, that's not going to change anything. That'll just be sine squared of A minus B. But this we got to FOIL out. So that's going to give us cosine squared of A minus B minus 2 cosine of A minus B plus 1. There's my sine squared of A minus B. We'll FOIL these two out. And you get cosine squared A minus 2 cosine A cosine B plus cosine squared B. The next one would give us plus sine squared A minus 2 sine A sine B plus 2 sine squared B. Wait a minute, I see a lot of sine squareds and cosine squareds here. We have some simplifying to do. Cosine squared A minus B plus sine squared A minus B. These two become a 1. Bring down the rest. So my minus 2 cosine AB plus 1. Then here, cosine squared A, sine squared A. That's a 1. Bring down the minus 2 cosine A cosine B plus cosine squared B plus sine squared B. That will be a 1. Oops, my arrow is a little off, so it should be pointing from this green line to here. Then we'll bring down the minus 2 sine A sine B. Okay, what can we do next? Well, let's combine some like terms. 1 and 1 is a 2. 1 and this one is a 2. Nothing else changed with my minus 2a minus 2 cosine A cosine B minus 2 sine A sine B. A lot of multiples of 2. Oh wait, this 2 and this 2 are exactly the same, so I can subtract 2 from both sides. We'll get those to cancel out. Yeah, there is a lot of factors, well, factors of negative 2 in fact. So let's divide these two terms on the right and this term on the left. Let's divide both sides by negative 2. And wait a minute, there's my identity. Cosine of A minus B equals cosine A cosine B plus sine A sine B. That's our identity for the difference of two angles for cosine. Now, well, if we have a minus, we also have to have a plus. So cosine of A plus B is using this identity, and we're going to substitute in a negative b for all the b's, because if you have minus and negative b, that'll turn this into a plus. So we'll substitute negative b into every b. Cosine of A plus B now will equal cosine of A. Well, this is your even identity. That's going to just be cosine B. And sine of minus b, or negative b, that will be negative sine of b. So what's going to happen is that this negative on this sine b has to be multiplied to this plus sign, and there'll be no change to the first term. So cosine of A plus B equals cosine of A cosine B minus sine A sine B. Now, if we look at these two, because you'll have to have these memorized, start to build a pattern. If you look really close, all these identities always keep A first, then B, A, and B. If it's cosine of A minus B, the first thing I notice is that the signs are opposite. If it's A plus B, it's a minus. Cosine A cosine B, cosine A cosine B. Sine A sine B, sine A sine B. So I just got to remember two things. Opposite signs, cosines first, sines second. And there's our two identities. All right, so to practice using those, let's say you define the exact value of the cosine of 15 degrees. Well, exact values come from 0, 30, 45, 60, and 90. Those were our special right triangle values. Well, wait a minute. What if I took 45 minus 30, or 60 minus 45? That would give me 15 degrees. You can choose whichever two you want. You're still going to get the same answer. So I'm going to go with 40 and 30. So A will equal 45, B is going to equal 30. So I'm going to rewrite cosine of 15 degrees as cosine of 45 minus 30 degrees, and I'm going to use this identity. So that means every place I have an A, I'm putting 45 in, and every place I have a B, I'm putting 30 degrees in. And now we'll find our exact values. Cosine of 45 and sine of 45, those are now committed to memory. We know those to be radical 2 over 2. So there's the cosine of 45. Cosine of 30, oh, let's see. Sine of 30 is a half, so this must be the radical 3 over 2. Plus our radical 2 over 2, and sine of 30, like I said, is 1/2. So square root of 2 times square root of 3 is the square root of 6. Square root of 2 times 1 is square root of 2. 2 times 2 is 4 for each denominator, so the denominators are the same. So the square root of 6 plus the square root of 2 all over 4. Top are not like radicals. You can't combine them together. Check my answer on my calculator. put it in the degree mode and say, hey, cosine of 15 degrees, that's that decimal. Type in my exact value, square root of 6 plus square root of 2 all over 4. Hey, it's the same decimal representation, so now I know I'm right. Find the exact value of cosine of 5 pi over 12. I hate radians here. Convert it into degrees. Now it's 75 degrees, so I'm going to now add the 45 and the 30. Hey, wait a minute. This is going to save me some time. Because the only thing that's different is the plus and the minus. So again, I'm putting in 45 and 30 for A and B in all the same spots, but the work is exactly the same except this plus is now a minus. So radical 2 over 2 times 3 radical 3 over 2 minus square root of 2 over 2 times 1/2. Crunch the numbers. The only thing that changes is the sign, plus to a minus. Check my answer. The cosine of 75 degrees is 0.2588 . Type in that answer. I get the same decimal. All is well. Find the exact value of, wait a minute, cosine 87 degrees, cosine 93 degrees. Those aren't perfect exact value angles, but see, cosine times cosine minus sine times sine, different, well, same angles, just in different trig functions. That's this identity. That's my sum identity because it's a minus sign here, makes this a plus. So A is the 87, B is the 93. Let's plug them in right there. Add those together, it's 180 degrees, and the cosine of 180 degrees is -1. You're done. All right, so we'll do this in parts. So here will be our part 1 for this section.